do question number 20. Okay, let me just do question number 20 first. So when you're done, when you're done, I want you to do question number 22. No, I want you to check here. Let me do question number 22. Let me do question number 22. You say use theorem 10. Theorem 10 to find the curvature. Okay, let me check theorem 10 on the textbook. I think so, it's there. Theorem. Okay. Theorem 10 is okay, to find the curvature. Let's check theorem 10. Theorem 10 is the curvature. The formula is K is the norm of this one cross product of second derivative of the vector function divided by the first derivative of the vector function, the link to the third. Be careful here, it's to the third. Okay, that's the formula. So now they ask you, okay, the question was found the curvature. Okay, found the curvature is the same, but okay, let's do 24, because 22, if you check 22, it's nothing. You just have to apply the formula. But 24 is much more mindful. Let's jump to 24. I want you, okay, if you I'm doing 24, okay? But if I do 24, I want you to do question number 25 and also do question number 22. It's the same process. It's the most easy one. But question number 24 is the most harder one. Okay? So let me do question number 24. Because number 22, it won't tell you anything. You just have to apply the formula, but question number 24 is much more deeper. Okay, question number 24, they give you the vector function, which is a t square, and you have the ln t ln t at a given point t 0 1. Okay, here you have the vector function. Here you have a vector function. Now take the first derivative and the second derivative. The first derivative, if you take this first derivative, we will have 2t 1 over t, and we can have here ln t, and we can have here plus 1, I believe so, because it's t, because here is t times 1 over t. It's just 1. The t will cancel out and you have 1. And the first one, you take the derivative for this one, you have ln t. Okay, it's just 1 here. Got it? So now the next one, you have this one, and now the next one, you can have the second derivative now. The second derivative for this one, the second derivative for the vector function, take the derivative for this one, you have 2, and derivative for this one, you have a negative 1 over t squared. Okay, and the derivative for this one, you can have the derivative for whole thing, because this one is a number. If you take derivative, you have 0. The derivative for ln t, you have 1 over t. Okay, let me check to make sure I get it right. Okay, this one is good, this one is good, and this one is good. I think so. Okay, because this one is 0, and this one is 1 over t. Okay, good. So now from here, everything changed now. You see the point? That given point mean t equal to 1. That's the meaning. You have to set t equal to 1. T equal to 1. That's why they give you the point. It's t equal to 1. I will explain to you when I come to class. It's t equal to 1. You can set it. First derivative of the vector function at point 1, we will have the first derivative of the vector function at point 1. We will have what? At that point, 1, 0, 0. We can have 2, 1. ln 1 is just 0, and you can have 1 here. Okay, so now the second derivative here, we can have here 2, and we can have here negative 1, and we can have here 1. Okay, you just have to replace t by 1, and you can have this one. So now go back to the formula here. Go back to the formula, and you can use the first one. You can use the cross product. Take the cross product, first derivative and the second derivative for the vector function. Okay, you take the cross product and you take the link. Okay, that's the formula. The formula for this one, for the curvature, remember, formula for the curvature is already given. It's just the link for the first derivative of the vector function, cross product of the second derivative of the vector function. The link divided by the link of the first derivative of the vector function to the third. Okay, that's the formula. Now let's take the cross product. If we take the cross product I, j, k, we can have what? 2, 1, 1. 2, negative 1, 1. Here we can have I, 1 minus parenthesis negative 1. Negative j, 2, negative j, 2 minus 2. And the 2 we cancel out, of course. Okay, and this one for j, for k vector, we can have negative 2 minus 2. Okay, just to make sure I get it right. Negative 2 minus 2. Good. Okay, and here I will have 2 I, and here is 0. Okay, here is 0. Don't write it down. And here is negative 4. I have negative 4 k. And now I have to take the link. Remember, here is the cross product of the first derivative and the second derivative of the vector function. Okay, now I have to take the link. The length for this one, you have to take the square root of this one square is 4 plus this one square is 16. Okay, this one square and this one square, and add them, and then it will be square root of 20, which is 2 square root of 5. 4 times 5 is 20. Okay, so now you have this one. Now let's take the length for this one, the first one. If you take the length for the first one, the first derivative, the length for this one, we can have the square root of 2 plus 1 plus 1. Okay, it's 2 square plus 1 square plus 1 square. It's just 4 plus 1 plus 1 is square root of 6. The length for the first derivative of the vector function is just the square root of 6. Because here is 4, 5, 6. Square root of 6. Okay. Now the curvature is just the length is 2 square root of 5 divided by square root of 6, and that's it. We can stop here, or we can just, you can also write down like this if you want, unless if you want. It's the same thing. Okay, either way is fine. That's it. That's the curvature. Okay, why we have only that number? Because the point is already given. Because of this one is already given, that point is already given. That's why we have this one. Okay, that's it. Now you should be able to do the rest. It should be good until I come back and we can do more work. Good luck. Be nice to your teacher. Yes, it is. Thanks, guys.